Hi everyone, and welcome to 11.3 Resistance Ohm's Law, and we're more focusing now on Ohm's Law problems. Okay, so in the last video that we just saw, we were focusing more on our conceptual understanding of how Ohm's Law kind of plays out if we change the resistance but keep the voltage constant. What happens to the current, for example, okay? But now what we're going to do is we're going to use Ohm's law, V is equal to I times R, and we're going to use the formulas, and we're going to calculate what the different numbers would be, okay? So just remember that resistance is a term used in current electricity to describe things like light bulbs, motors, heaters, stereos. Another way of saying resistance, we could also call them loads, because they actually convert the energy that the electrons carry into other forms, and while they're doing that, they do so with resistance. Okay, things with a lot of resistance need a lot of energy to make them move. So, for example, let's just say we had a heater. A heater actually uses a lot of energy, actually, much more, for example, than a light bulb. Okay, so if you can imagine, as we're heating up something, okay, the air or whatever, it takes a lot of energy, which means it provides a lot of resistance, and it slows down the electrons quite a bit. Okay, things with little resistance don't need very much energy at all to make them move. Okay, in both models, resistance makes it hard for electrons to flow. Resistance is often described as the opposition to the flow of current. Okay, and we use ohms, OHMS, like ohm, okay? And it looks like the Greek symbol in terms of the unit. The symbol is this omega, which is the Greek symbol in the alphabet. And it looks like, I think it looks like, a shoulder with a head in between. I don't know, whatever, okay? Like, like just like this, okay? So in case you forget. Okay, so we talked about the different like V, I, and R and how they affect each other. That's kind of like what this is saying. But basically what we're going to do now is use the equations, okay? So Ohm's law states that the potential difference between 2 points on a conductor is proportional or directly related to the electric current flowing through the conductor. I don't think that makes any sense to you as a grade 9 student, but if you can understand that, that's great, okay? But we did talk a little bit about that in terms of like directly proportional or directly anyways, we did that in the last lesson. Okay, I'm just gonna keep going. Okay. So just remember, what we can do is when we have a formula using these three variables, we can once again, just like our density magic triangle DMV, okay, we can do something very similar since V is equal to I times R. So over here, if we don't know what the voltage is, we can cover up the voltage, and then we just read the magic triangle. They are side by side. When they're read horizontally, it means that there's multiplication between these two. So it's V times R, okay? And then if, for example, we don't know what the resistance is, we can find it out by reading the magic triangle, and then the formula would be V divided by R. So when it's on top of each other, this is like division, so V divided by R. And then on the other token, if we don't know what the current is, I, then we cover up the I, and it's equal to V over R, or V divided by R. Okay, so these are the three important formulas that you will use in order to calculate problems using Ohm's law. Okay, as mentioned as well yesterday, or in the last lesson, I mentioned that we would have a little chart. So this is very, very important right over here, okay? So please remember that there's different symbols. V is for voltage, I is for current, R is for resistance. So the weird one is current, because current has the symbol I, and it's measured using the units of amperes. So this one in particular is a little bit confusing. Voltage, volts, potential difference, okay, resistance, ohms. We just want to make those associations. So please have this worksheet available or this note available whenever you're doing your problems, okay? Now what we're going to be using is the GRASP formula, way of solving the problem. So it's kind of like, it's listed here, but in a little bit of a different way, okay? but if you remember, we used GRASP or similarly GRAS. I think I use GRAS in this case. It doesn't even matter, okay? But givens, required, analysis, solution, and then statement or paraphrase, okay? So we're going to be using GRASP in order to calculate these, find out the answers to these questions, okay? So I'm going to give you a few different examples, and then you're going to complete the rest of the questions for homework, or basically classwork, okay, since we're going to have some time to do them in class. Each question is worth 3 marks, okay? So let's just take a look. I've indicated which ones specifically I'm marking. You can also do 7 and 8. I just removed them to like shortlist them. They're a little bit more challenging, but please, if you like a challenge, please go ahead, okay? You will be completing these on a separate piece of paper. I do have some scrap paper at the front. I don't know, or actually it's probably better just so that you don't use one of my worksheets by accident, okay? But you can just ask around, see if anyone has paper, if anyone is missing paper, okay? Okay, so this is worth marks for homework, okay? Let me just show you what it is that we're doing, okay? So for example, question number 1, this is in red right over here, okay? So what is the current? So immediately I know that what's required, the R, the required aspect is I, which is current, and it's produced by a potential difference. Potential difference is V, which is voltage. And it tells me that the voltage is 240 volts. Okay, so I'm just writing down the different givens and the required, okay? And then it's through a resistance of 0.2 ohms, okay? So I'm just recording my givens and required. So I have my V, which is 240 volts, my R, which is my resistance, and I'm going to make sure I put down the units of ohms. And then what's required is the current. I don't know what it is, and I'm going to calculate it. So I is equal to, I don't know. Okay, my analysis is I have to write down the formula. So if I'm looking for I, I'm going to cover up the I, and it's going to be equal to V divided by R, V over R. You get a mark for using GRASP, okay? But basically you get a mark for writing down the formula. You get a mark for filling in the proper values. So my V is 240, my R is 0.2 ohms, okay? You get a mark for that. And then finally, you get a mark for dividing it out and then giving me the final answer with proper units. So I'm going to do 240 divided by 0.2, which is 1,200. I have to recognize, okay, what I'm required to find is I, which is current, and what are the units for current? They are amps. Okay, so you're definitely going to like flip back and forth. You're going to look it up over here. So if it tells you that the potential difference is something, right? Maybe you haven't associated with it the fact that it's, you know, associated with V, so you just look it up, okay? If I know I'm looking for I, it's unknown, I can just look up, hey, my units are amps, okay? Now I'm just going to tell you what are some common mistakes, okay? So some students are able to get the fact that, hey, the number is 1,200, so it's 1,200 amps, but common mistakes are to say something like, okay, well, I don't know what the I is, so students sometimes put down 1,200 I, or you might even say something like 1,200 current, okay, for example. Those are not proper units. You want to make sure you have A, which is amps. Okay, this is your final statement. So therefore, the current is 1,200 amps. Okay, sorry, it's very squished, but I just want to be able to see the questions as well. Okay, so we've done the first one. Let's do the second one. The second one is in blue. Okay, so what resistance? Okay, so that means that my required to find is my R. I don't know what the resistance is. What resistance would produce a current of 120 amps? So just remember, current is I. So I have I is 120 amps from a 6-volt battery. So V is 6 volts. So here are my givens and my required. If I'm required to find R, what I'm going to do is go up to my magic triangle, and I always recommend that you just recopy it somewhere that's on your worksheet, okay? So I'm going to cover up the R, then what's left over is the V over I. So I'm going to write that down. You get a mark for writing down R is equal to V over I. Then the solution would be to fill in the numbers. So 6 volts, and I just read it from my I and my V here. Make sure you don't just put in, for example, sometimes students will feel uncomfortable and they will not want to divide a small number by a big number, okay? But we must follow the formula. We must not say 120 divided by 6 just because we feel uncomfortable with it. We must follow the format of the formula, okay? So it's V divided by I, 6 divided by 120, we get 0.05. That's the number, but we still must put down the unit as well. So if you don't know what the unit is of ohms, you look back on the front of the worksheet. Okay, I know I'm looking for R, so then I look up the unit. The units are over here, VA or ohms. Okay, so then it's going to be 0.05 ohms. You get 3 marks. Okay, half a mark for the number, half a mark for the unit as well. Okay. For question number 3, similarly, okay, so I'm not going to like go over it. Actually, maybe I will go over it, okay? But the main thing here is potential difference is V, that's what's missing. R is 25 ohms, I is 250 amperes, so there it is right there. Now I'm looking up V, so V is equal to I times R, because what I do is I'm covering up the V, it's equal to, and I'm reading it horizontally, I times R. So I write that down, I get a mark for that. And now I'm filling in with the units, 250 amps times 25 ohms. I get the answer of 6250, 6,250, okay? Then I have to make sure I have the proper units. The units for voltage is volts. That's how you get your full 3 marks, okay? So GRASP, okay, sorry, anyways. And then this would be S, and then the P, or the final solution, would the final answer would be therefore, blah, blah, okay? I actually, you know what, everyone? I think I don't give you marks for doing the paraphrase because, like, it's overkill. So if you just follow GRA, or if you follow, like, if you put down the G and the R, I think that's really helpful. It sets up good habits for later on, okay? And then make sure you write down the formula, make sure you fill in the values, and make sure you give me your final answer with units. So you'll notice I don't give you marks for the G and the R, but I do recommend that you write those down. Don't worry too much about the 2 S's, like the final paraphrase, okay? So everyone, you are going to finish off number 4, 5, 6, 9, 10, 11, 13, and 14. That's 8 questions. Each were 3 marks for 24 marks, okay? This is going to be an assignment. Yeah, okay, so go ahead and do that. One last thing, I think, is I do also want you just to read through page 458 and 459. There's a short bio on George Ohm. I just really like it because I think he was like a high school teacher or something, and like his discovery of Ohm's law was so groundbreaking. Ohm's law actually gave rise to things such as batteries, like portable batteries, transformers, generators, okay? Without George Ohm, who was like a high school teacher, like understanding the relationship between voltage, current, and resistance was so groundbreaking at the time. And so yeah, anyways, so please read through those 2 pages. You'll notice that I did link all the stuff under content, under unit 1 electricity, under current electricity, and then under mark 28, 29, okay? I put down the textbook right here, 11.3 textbook. Please read through page 458 and 459. And then just in general, read through all of 11.3. Maybe do this tomorrow, actually. Yeah, maybe do this tomorrow, actually. Okay. Okay, so read through page 458 and 459, okay? Just do that for today. And then tomorrow, I would like you to also just read through all of chapter 11.3, okay? Okay, everyone. See you later. Bye.